Good.
Okay, sorry about that, everyone. So I'll just back up a little bit. I'm not sure what everyone heard, but today's presentation is on clinical data conversions, some functional and technical considerations. And I just wanted to note that during the presentation today, your phone has been automatically placed on mute. So if you do have a question, just use the Q&A panel on the right side of the screen. Okay, so my name is August Borey. I'm an enterprise EHR consultant with Galen Healthcare. I've been with Galen for a little over 2 years, working on conversions as well as implementations.
And my name is Fallon Hartford, and I'm an interface analyst at Galen. I've been with Galen for about a year now and primarily work on conversion and reporting work.
Okay, thanks, Fallon. So I did just want to go over a quick overview of what we'll be covering in today's presentation. So we'll be talking about, first of all, why there are so many decisions to make when performing a clinical data conversion, and then we'll go over some functional considerations, a few technical considerations, and then we'll cover a few gotchas or lessons learned that we've had experience with while performing data conversions. And then at the end, you'll have an opportunity to ask your questions as well. So to start off, why are there so many decisions? So there are many decisions to carefully consider when you're getting ready to perform a clinical data conversion. So you may be thinking about, in terms of a conversion, why is there so much to think about? You know, aren't we just transferring data from one system to another? And while the answer there is yes, there are many things that you want to think about when you're transferring data from one system to another to ensure that the data is transferred correctly and to ensure the data integrity of the target system. So depending on what data is being converted and maybe how long the users have been inputting data into that source system, there can often be a large amount of data that's going to need to be imported into the target system. So we want to make decisions that don't require us to have to go back at the end and change that data or modify it in some way. You know, in some cases, it's very difficult to change this data once it's been fully imported, and in many cases, it's actually not even possible to do that at all. So we want to make sure we get it right the first time, which is why we do so much testing during the conversion process, data validation, things like that. And so unless you're converting during a conversion, a clinical data conversion from the same EMR to the exact same other type of EMR, then those two systems, the source system and the target system, are going to be different systems. And so different systems inevitably are going to record and store data in two different ways. So sometimes the functionality of one system is not going to be available to users in the other system. So for example, maybe one way the source system may store a medication refill may be different from the way that the target system stores that medication refill. So looking at how that data is stored, and you may have to make decisions on how that data is going to be converted if you want that data to be converted. So organizations also need to be conscious of how the converted data is going to fit into the global context of the system. And what I mean by there is a target system. So by global context, we're talking about how the EMR, the existing EMR, is structured for all existing users. So for example, maybe mapping a commonly used medication from the legacy system to a very specific medication from the target system that's not really used in the current workflows in that target system might not be a good idea. It may be confusing for users to see that medication on that patient's chart in the target system. So those are some things that we want to think about. And now, you know, a few things that you may be wondering what types of decisions need to be made. So define the scope of a conversion. So the first one is scope. So define the scope of a conversion is extremely important because that's what's going to define exactly what data is going to be converted as part of the project. And so it's really important to define that very early on in the project because as the project goes on, it's easy to find more and more items that you might want converted. And this can do things like impact the timeline of the project, extend the go live, things like that. And the next one is mapping. So I briefly touched on mapping, but mapping represents a large portion of the work that needs to be done in a conversion project. So what we're talking about here is mapping or matching up an item from the source system to an item in the target system that's the same. So the mapping determines the nomenclature for how the clinical data is going to look from one system to the next. And then we have workflows. So there might be conversion-specific workflows that need to be thought out. and that users will need to learn in addition to the workflows that they're going to be learning as part of just the everyday use of that target system. So one example would be the verify and add workflow. Oops, sorry. So converting data as unverified in the case of unverified problems or medications, and there's a few others, and we'll talk about those a little bit later, those require a distinct separate workflow in order to render that item as usable in the system. And we'll actually take look at an example of that verify and add workflow. And then another challenging aspect that we think about is that we're often making decisions as part for the conversion for a large amount of data based on a much smaller subset of data. So that's why it's really important to do things like the data validation in that phase of the system and just really get an idea of what the patient's chart is going to look like in that target system. Okay, so now we'll cover a few functional considerations when performing a clinical data conversion. So I do want to mention that the majority of the information we'll be covering in the presentation is geared towards converting from a legacy system, really any legacy system, to Allscripts Enterprise EHR, but the concepts can be really used for converting from any source system to any target system. So one thing I mentioned a little bit ago was scope. So defining the scope of a conversion is a chief component when it comes to determining the success of a project. And that's because each organization is going to have its own needs when it comes to exactly what data is going to be converted. So as you may be familiar with, there are really 8 major data types when it comes to a clinical data conversion. You've got immunizations, allergies, medications, results, problems, documents, vitals, and then images. So just in some cases, not every data type may even be present in the source system. So it may be easy to discount one of the data types. For instance, if an organization doesn't have an inbound results interface, then there won't be discrete result data or lab data to extract. So that obviously won't need to be converted. And then there are multiple filtering options that organizations can use as well to determine what data they want to convert. So for instance, maybe we're converting only for a certain group of patients, data for a certain group of patients, or it may be an internal organization of patients. Maybe we're converting data only past a certain date or for a certain group of providers. So there's multiple options that organizations have when they're choosing what data to convert. And then another thing that can help clearly define scope is going to be understanding both for you and the team that's performing the conversion to understand and agree on where the fields from that target system are going to appear in the source system, so where they're going to display in both systems. So for example, if we're talking about a medication, knowing and understanding where maybe the quantity or the number of refills is going to display in both the source system and the target system. And this knowledge will be very helpful when it comes time for testing. And then just setting expectations for what fields can actually be converted at all. So all fields might not be available to be converted. So once the conversion technical analyst has had a chance to analyze the data in the source system, he or she may come back and say that these fields are available to be converted, these other fields are not. So now I want to touch on the current medications versus medication history. So organizations have a couple different options when it comes to converting medications during a conversion. They can choose to only convert the current medication list for a patient, or really convert all the historical medications for a patient as well. So if we're deciding to only convert the current medication list, this is going to produce the most recent record of the medication. So the last time it was updated, the last time it was edited. And depending on how that source system stores these records, they may not always be the last time that the medication was prescribed. So some systems may record a medication every time it's cited into a note, for example, or every time it's just updated or edited in some way. And this may not always be done by the provider. So that's just something to keep in mind, that it may not always have the ordering provider on that medication if you're just converting the current medication list. Now, converting the entire medication history, this can obviously bring a lot of valuable information over in the conversion. However, it can clog up the chart a bit. If we're talking about converting each time the medication was prescribed or refilled, we're talking about multiple line items, multiple medications in the chart. So for instance, if we have a medication that was prescribed and refilled 5 times, then each of those records is going to convert separately as a different line item in the medication list. And this can just be a little bit confusing for users that are going back and looking at the past medication list for a patient. It can just look very long because each one of those past medications is converted separately. And then we can talk about scanned images. So a scanned image conversion is often one of the most time-intensive data types to convert compared to the other data types. The image files, the actual scanned image files, are generally stored in their own separate folder on the legacy server, and they have to be processed and transferred to the enterprise scan warehouse, where they're going to reside so you can view them in enterprise. And so just a little bit, what we're talking about with scanned images, we're talking about those pieces of paper that are being scanned into the chart and just stored as a digital image. So one of the reasons these files take longer to process and the scanned images take longer to convert is because those physical files that reside on the server have to be actually picked up, processed, and then imported into enterprise scan. And then a lot of times organizations also have a large number of scanned images. So that's another reason it can take a little bit longer. And Fallon will actually be talking about some of the technical aspects of a scanned image conversion a little bit later in the presentation. So when we're talking about configuring or things to think about when performing a scanned image conversion, there are a couple places where the configuration must be performed in order to support a scanned image conversion. So one, we've got the chart in Enterprise EHR, and then the other place would be in the folder structure in Allscripts Document Management, also known as ADM or SCAN, so that application as well. So when talking about configuring or build in Enterprise EHR, there are a couple of different options when it comes to deciding where those images are going to reside in the chart. So one method can be to convert those images into an existing chart structure. Obviously, one has to exist. And then the other way would be, if it's a net new system, obviously there won't be an existing chart structure, so one will need to be created for the conversion. So integrating into an existing chart structure, that can be advantageous because then users don't have to look in a different section to find those converted documents. So if you do choose to convert into an existing chart structure, you can either create new document types for those converted images, or if those document types that are already built really match up well to the different image types or document types coming from the source system, then you could just utilize the existing ones that already exist in Enterprise EHR. You can do that as well. So one option, if we're talking about creating new document types, so say that really the image types from the source system don't really match up to any of the existing document types that have been built. One option you have is when creating new document types to indicate in some way with the name of the document type, where the scanned image came from, maybe what practice it came from, what type of system it came from. So maybe if we're talking about a paper scanned result that's scanned into a legacy system of eClinicalWorks, then you could create a document type and map it to a document type named ECW for eClinicalWorks, then CONV for conversion, and then just the imaging result to indicate what it is. And then anyone looking at that image in Enterprise will see that it came from the legacy system as part of a conversion and what that image is, what type it is. Then the other option that you have within Enterprise is to build a totally separate conversion section of the chart, or a legacy section of the chart. And then any converted images are going to file under that section. Obviously, if you're going this route, new document types will need to be built. Since existing sections of that chart aren't being used, it's a totally new section. And one reason you might want to do this is, say you have a large number of images being converted. So converting these images into an existing chart structure, it can make it a little bit confusing or cumbersome for users that are trying to find both those images that are being converted and also those images that are being scanned into the system on a daily basis. It can just be a lot of images to look through. And then so if a decision is made to build new document types as part of the conversion, then folders also have to be built in the scan warehouse or the scan application, Allscripts Document Management, to support the images that are going to be filed there. And oftentimes what we see with organizations that are doing this, they choose to build a brand new chart group in SCAN to support the conversion, and in some cases, future conversions as well. And this just segregates the conversion folders since they're not likely to be used on a regular basis just for conversions. And it just keeps them in a separate chart group so users that are scanning images on a daily basis don't have to look through those folders to find the ones they're looking for. So let's just take a look at a screenshot of that actually. So this is an example of a separate SCAN chart group within Allscripts Document Management. So you can see we have a chart group highlighted called Legacy Chart Folder. And then on the right-hand side, we've got a bunch of document types that were built to support the converted scanned images. And they're just kept in a separate chart group from the rest of the chart groups. Okay, now I want to talk about annotations. So you may be familiar with annotations in Enterprise. So in Enterprise, it's possible to add free text comments on different clinical items such as medications, allergies, or immunizations. And these free text comments are known as annotations. And the good thing about these annotations is that they can be a destination for any converted data that doesn't really fit into any of the discrete fields in Enterprise. So one common annotation that we see a lot of times with conversions is just a small blurb stating maybe where the clinical item came from, what system, and what practice, something like that. So for instance, if you had a practice coming, let's just use the example of eClinicalWorks again, you might create an annotation and say, I want this annotation to be on every single clinical item that gets converted, saying something like clinical data came from eClinicalWorks on such and such a date from such and such a practice. And that just lets anyone looking at that clinical item know, where the item came from. It wasn't added manually in Enterprise. And then another example or another use of the annotation field that we see is to really populate it with data that can't be mapped to any discrete fields within Enterprise. So one example that I did for previous conversion is that there was certain VIS or vaccine information statement information that didn't really translate to any of the fields within Enterprise. So we brought that over as an annotation. And I just want to mention that there can be multiple lines of text for an annotation, so it's not like you have to choose one or the other. You can bring over multiple lines for multiple different reasons, and we'll actually take a look at an example right now. So here's a medication that was a part of a conversion. And down at the bottom under the annotation section, you'll see there are actually 3 lines of annotations, and they each say something a little bit differently. So the first annotation was just the name of the medication, and that's what the organization had chosen. And then the second line looks to be some free text that was on the medication in the source system. So that's another place, another reason that we might create an annotation as part of a conversion. If there was some, just like we can add free text in Enterprise, there may have been some free text on the clinical item in the source system, so you just bring that over as an annotation as well, as a comment. And then this organization that did the conversion also wanted the pharmacy information for the medication to display as an annotation as well. So we can do a number of different things like that. Okay, and then we're talking about providers when it comes to a clinical data conversion. So providers are another data type that will need to be mapped in order to convert the correct provider that's associated with all the clinical data that's coming over from the source system. So obviously one benefit to mapping all these providers is that it allows the providers and the provider names to follow their clinical data to the new system. And like I mentioned a little bit earlier, one thing to keep in mind is that a provider may not always be associated with the clinical item or the most recent record of the clinical item in the source system, which is what we usually extract. So that's just something to keep in mind, is that the true ordering provider of, say, a medication or a result may not always be on that last instance of that clinical item. So say you didn't want to map all the providers. So what we do then is we create a generic quote-unquote conversion provider, and this really just signifies where the data came from and also takes the place of a true ordering provider there, since a lot of times for many of those data types, that does require, or enterprise does require, an ordering provider on those items. So a common practice that we see is to include in some way the legacy system or the legacy practice that the item came from in the name of the provider. So for example, if we've got the name of a practice that's being converted called Heart Medical Clinic, and they're converting from Allscripts Professional EHR, then you might create a provider named Conversion MD, Heart Pro, or Heart Pro Conversion MD Provider, something to that effect. Then anyone that's looking at that item just sees that on there and knows where that item came from. And then there are also a lot of times non-provider users attached to clinical items as well. So for instance, the administered by provider for an immunization or medication, or then even the recorded by provider for any of those clinical items as well. And in many cases, these non-providers, if they're going to be converted discretely, then those need to be mapped as well, in addition to mapping the providers. And since there's often many more users of an EMR system than providers, sometimes this can be quite a time-consuming task to map all those non-providers. So then we can also go back and add that non-provider information as an annotation, like we just talked about. So as an annotation on an immunization, for example, you could make it say recorded by or administered by, and then the user, the name. You don't have to map all those non-providers. So you've heard me talk a couple of times about unverified items or unverified data when it comes to conversions. So unverified items are one really important feature that enterprise has when it comes to converting data. What this means is that instead of the item converting discretely and displaying with the title or the name of the item that it was mapped to, it really just converts as a free text item in the chart. So really it's going to read as whatever it looked like in the source system. So you may be familiar with unverified items in the sense of unverified results during the daily use of enterprise EHR. However, the unverified items that we're talking about are a little bit different than that. So while those unverified results are unverified, they're still discrete data in enterprise, and they're just signifying that the providers need to look at those results and verify or sign off on them. We're talking about converting data as unverified, meaning that someone needs to go in and manually match up the unverified item to a discrete item or a dictionary item in enterprise. So you may be wondering why organizations would convert items as unverified. One reason would be it doesn't require any time to map, so it can significantly decrease the time it takes to map the different clinical items. In some cases, we're talking about thousands of items to map. So it can be a very time-consuming process. So choosing how many items to map can depend on the way in which the entries are stored in the source system. So for instance, if a legacy system stores a large amount of free texted entries, meaning that users can just go in and type in the name of medication rather than choosing from a list, or type in the name of a problem rather than choosing it from a dictionary, attempting to map every single one of those values can obviously be very, very time consuming. So the benefit to converting these items or items as unverified is you don't have to map any of them. And then also it allows users to build a patient's history of the unverified items really on the fly when the patient comes in for the next visit. So if there are a lot of items that maybe were free texted in or that are a little bit ambiguous from the source system, you can convert them as unverified, and then the next time the patient comes in for the visit, go down through the list and verify them all. So obviously in every case, there's some downsides to unverified items. Because the items aren't discrete, they're just free texted, they don't really have the same functionality as a discrete item would. So meaning that if we're talking about an unverified medication, let's say, a user can't right-click and renew that medication or discontinue the medication, or really perform any of those common actions that you would on a normal verified med or discrete med. In the case of an allergy, for example, those don't participate in DUR or drug utilization review checking. So if a medication is prescribed that would normally throw an interaction flag with that allergy, that pop-up, that warning is not going to display because that allergy is not verified. And then items like medications and allergies, unverified items like medications and allergies and problems, they don't automatically cite into a note. So only items that are part of the discrete list cite into a note. And then immunizations. Those are going to display under the orders component on the clinical desktop. And this can just be a little bit confusing because users are used to going to the immunization series component of the clinical desktop to find the immunizations. However, unverified immunizations are going to display under the orders component. And then also providers can't assess and charge for unverified problems. So just a few of the downsides to converting items as unverified. So now you may be wondering, well, we've gone and converted a whole bunch of items as unverified. Now how do we actually verify those items and get them in the discrete list in Enterprise? And that's called the verify and add workflow. And I touched on it a little bit, but this is something, especially if you're converting a lot of unverified data as part of the conversion, that users are going to need to become very familiar with. So this workflow involves matching the unverified item to one of the dictionary items in the ACI. And we can actually implement logic that's going to pre-populate the search box in that ACI with the text of the unverified item, so it can make it easier for users to find that item. And then if an item, you determine that you don't want that item, it's no good, it's really easy to just remove that unverified item. So now let's take a look at an example of that workflow. Just going to log into my test system here. Okay, so I'm in the test system Enterprise, and I've got a test patient pulled up, and I'm on his active problem list. So you can see up at the top, this problem of asthma, that's a discrete item. That's a discrete problem. However, down below here, we've got 3 unverified problems. So unverified data is going to show up under this unrecognized unverified section, and that's just what's called in Enterprise. So the workflow here to go ahead and verify this data is to just right-click on the problem and go down here and choose Verify and Add. So I'm going to click Verify and Add. It brings up the ACI. And like I mentioned before, we can implement logic that's going to pre-populate this search box here with really whatever you would like. So in this case, I chose to pre-populate it with the ICD-9 code from that problem. Then it automatically pulls up every single problem in the dictionary with that ICD-9 code. So then I want to match it up. I'll say it's this one right here. Check it off, click OK. And then you can see it now pulls up underneath the discrete list here, under the chronic active problem list. Now it does still display down here, but as soon as I go and click Commit, click Save and Continue, you can see that it goes away from the unverified list, and now it's under the discrete problem list here. And like I mentioned earlier, it's very easy to go ahead and remove an unverified item, unverified problem in this case. All I do is right-click on it and choose Remove. And now it's gone from the unverified list. So say we don't have, or we're trying to verify a problem that's not a diagnosis. So in this case, it's a social history problem for a smoker. So you can see the name of the problem as it was entered in the source system is smoker. And then it looks like there were some comments on this problem as well. So someone had commented or written a comment on this clinical item in the source system that said 1 pack per day. So if I go ahead and right-click and choose Verify and Add, and now I populated the search box with smoker, so we can also populate it with any characters or free text as well. So it doesn't have to be an ICD-9 code or anything like that. And then say I'm going to choose current everyday smoker. Click OK. Now you can see current everyday smoker is showing up under the health maintenance / risks. And as soon as I commit it, now it just says current everyday smoker. So we lose that comment that was on the item. That's just one thing to note, is that when you're converting items as unverified, we can convert dates, we can convert comments, free text on that item, but as soon as you go to verify it, it's not going to cross over, so that needs to be added again. that's just something to keep in mind as well. But it can be very helpful for the user that's trying to go ahead and verify that item. And that's pretty much it for unverified items. Each item is going to show up under its respective section. So these problems showed up under active problems. Allergies would show up under the allergies section. Same with medications as well, would show up under the medication section. Okay? There's our demo there. So there are a few preferences associated with a verify and add workflow. There's enable allergy verification, enable problem verification, and then enable RX orders verification. So all three of these preferences must be set to no for any of those users that are going to be running that verify and add workflow or performing that workflow. If those preferences are set to Y for those users, then the verify and add and remove options that I just showed you are going to be grayed out and disabled when you right-click on the unverified item. So it's just really important to make sure for those users that are going to be following this workflow to set those preferences to no. And now we'll talk about a few mapping considerations. So I've mentioned mapping a few times in the presentation so far, but again, mapping is one of the major aspects or major pieces of the conversion project as a whole. It's going to define exactly how that item is going to display or how every item is going to display in the target system. So there are just a few things that you want to consider when you're getting ready to perform the mapping. So one thing would just be counts. So counts can be really helpful, and your conversion technical analyst can provide the counts of those items for each data type when you get to the mapping workbook. So those counts are essentially, how often each item is used across all of the patients in the source system. So, starting at the items with the highest counts and then moving down the list is a really good way to go about prioritizing the mapping and those items there. One example would be when it comes to problems, I've seen organizations just map all of the problems that occur more than once. So all of the problems that have a count greater than 1 in the source system. And this just allows a great percentage of the items to be mapped without spending time on those items that are only used once in the source system. Those can be converted as unverified. And then there's a decision to decide what items to exclude from the conversion. We can exclude items as well. So typically, as part of the conversion, we exclude items like no known allergies, no known drug allergies, no known medications, things like that. And that's really because every system, every EMR is going to record those statuses a little bit differently, so it can just lead to a loss in data integrity if we end up converting those statuses as discrete values. And then other items can be excluded as well at the discretion of the organization. So that's just one thing that can be done during the mapping, is going down through the list of the items to map, deciding what you do want converted and what you don't want converted. And then we also want to think about why values may be present in the different data types for mapping. So in some cases, there may be data types that reside, or items that reside in a certain data type, which clearly don't belong in that data type at all, or maybe it's a little bit confusing why they do belong there. So I've seen cases where active problems were added to the allergy section of a chart, and then when we do the extract of the data, they show up in the allergy mapping section. So, and it seems strange that the items could be added in the wrong section originally, but every system is a little bit different, so there may be a reason for that. So they may actually need to be there based on how the user was interacting with that source system. So it's just important to think critically, think about why the items might be there. Maybe they can be excluded, but maybe they're there for a reason. Then it's also important to think about, take into consideration how those items that you map to are going to display in Enterprise. So, and this is especially significant when it comes to problems, in my opinion. Problems, as you know, can reside in a number of different categories. We've got past medical history, family history, social history, etc. And each of those sections can have its own specific language. So you want to think about how that item you're mapping to is going to display in that specific section. So for example, past medical history, when you read the problem in Enterprise, it shows and reads as history of. For family history, it reads as family history of. So really understanding it and thinking about how that item is going to read in Enterprise is important as well. And then there may be some ancillary mapping needs that you might have. So in addition to those 8 major data types, and in addition possibly to the providers, the non-providers that I mentioned earlier, there may be some more mapping exercises that need to be done depending on the information that the organization wants to be converted. And also what items and what information is actually stored or recorded in the source system as well. So if we're talking about medications, immunizations, and we want the route of administration, body site, and manufacturer information to be converted, those are all discrete values and discrete data dictionaries in Enterprise. So if those items are to be converted discretely, we need to map them as well. And as well, allergy reactions is also a dictionary in Enterprise. So if those items are to be converted discretely, we need to map them as well. So depending on what items you might want to be converted, there may be some more smaller mapping exercises to do in addition to the big ones. And then another thing to consider is where the item you're mapping to came from. So a few of the data types that we're talking about, like medications and immunizations specifically, Enterprise actually allows you to manually create your own entries in that dictionary, in those dictionaries, in addition to all the delivered content that's there. So those custom created items, those manually created items, they don't pass through that checking that we've been talking about, that DUR checking. So if you were to map an item to one of those an item from the legacy system to one of those items that was manually created, when that item gets converted, it's not going to pass that checking either. So you just want to be careful of that too, that you're not mapping items to manually created items. And then for results. So if there's lab result data or other types of result data being converted, there are a couple different options you have there. So obviously the first one is to map all the discrete lab results for the conversion. And this actually might be not that bad of a process because sometimes this can involve loading a new lab compendium into Enterprise to support that clinic that's coming on board into the system to support their orders and results in the future. And then we can use those items that are being created as part of the compendium to map to for the results for the conversion. And this is often going to capture the majority of those results, but it may not capture all of them. So if it doesn't capture all of them, then you have a couple more options from there. We can either create new items in the orderable item dictionary and resultable item dictionaries to map those items from the legacy system to that are left over, or the other option is to use the auto-filing process. So what this process does is it's automatically going to create items in the OID and RID based on how the data is extracted or how the data is worded in the source system. So if you have items and results that aren't mapped and that are being used as part of that process, then the conversion is going to create items in each of those OID and RID dictionaries, automatically map those values to those newly created items, and then file the results discretely. So, you can think one big drawback of this would be if you're converting a lot of data, a lot of lab results in this way, it's just can fill up the OID and RID dictionaries, which is not always preferred. So that's just something to keep in mind as well when attempting to use that autofile process, because most often those dictionary items aren't going to be used again after the conversion, so they'll just be sitting there. And then finally, I did want to put unverified items on here. I know we touched on it pretty extensively earlier, but it really is a pretty big mapping consideration, so I just listed it here on this slide. And then also creating a valuable conversion team is very important. So you want to think about the team that you're going to have when getting ready to perform a clinical data conversion. One of the biggest things in my experience for conversion projects to push their go live and extend the timeline out is that organizations don't really realize the number of hours that are going to be needing to be put into things like mapping, data validation, the testing period of the conversion. So if we're talking about a discrete data conversion, mapping those data types, like I talked about, can be very time consuming. So there are often thousands and thousands of items to go through. And some of those items, like medications and problems, they also require clinical input. So it's very important to have a clinical resource, on the project, dedicated to the project. And then it's also helpful to have analysts who have experience with both the target and the legacy systems. This is going to add value in a number of different ways. It's going to add value during the testing phase of the project, when data is going to need to be validated between both systems. That's what we see is the best method of testing or validating the converted data, is to really pull up both systems, look at the data between the two, and compare it, make sure it looks correct. And then also it's important when it comes to testing is testing the different workflows with the converted data. So having people who are available and who know both systems enough to test the different workflows in the target system. This is just going to uncover any differences in the behavior of the converted data versus any manually added data. So sometimes just looking at the two systems isn't always totally evident for any differences that you may see once the data is actually being used on a daily basis. And then it's also helpful to have a technical resource available for not only setting up access initially to the data, but then during the conversion project, if there are any questions about space on servers or backups or things like that, just to have a resource either on the project or available if needed. Okay, so that wraps up the technical considerations, so I'm going to pass control over to Fallon, who's going to go over some functional considerations as well.
Thanks, August. There we go. So I'm going to go over some of the technical considerations that are important to keep in mind beginning before the contract is signed all the way through go live. So August had previously mentioned the importance of creating a valuable conversion team. Communication between the members of the team, both on the client side and on the technical side, is really key to the successful project implementation. The conversion analyst is going to be very familiar with your data, but they'll have questions about the workflow of the practice, and they'll need help with building out their extracts, sort of, understanding that data. It's also helpful to know the needs and the wants of the organization that the data is being converted to. So some clients may want data to be converted exactly as is in the legacy system, and some may want to see more or less information in the target system. So before the contract is signed, decisions need to be made on what type of conversion will be best for the organization. There are two options of how to get data into the chart. There's a non-discrete conversion and there's discrete conversions. Non-discrete conversions generate data into a chart summary to be imported into the patient's chart in the enterprise EHR. These are generally less work for both the conversion analyst as well as resources on the client side, since there'll be no mapping of data, as we talked about previously. It's also easier to test this type of conversion since there's no worry of data being duplicated in the EHR, as they're converted as a scanned image and a snapshot of data from the legacy system. Something that should be considered about this option is that the data is not reportable. So the only way to view this data is by opening the chart summary so that the data can be referenced but not incorporated into the workflow. I have an example chart summary that I can show you. This was prepared for one of our clients, showing some test data in here, and you can see that it can be completely customized to the organization, the needs and the wants of the organization that the data is being converted to. You can see here that we have a cover page. It describes where the data is coming from, along with a table of contents to tell you what pages each of the data elements are located on. And so we have the problems. You can see the past medical history and the social history. Allergens. One thing I just want to note, you might remember that August had mentioned that we don't convert no known drug allergies, but he was talking about the case of discrete conversions. During the non-discrete conversion, we will have the ability to put that information in the chart summary. Just scrolling down, we can see the medications, any vitals that were taken, and any immunizations if that's applicable. So discrete conversions, on the other hand, involve inserting legacy data into the database of the target system. This option has many benefits. It is reportable, so that means that you can query the data and include it on custom reports and along with other reporting measures. And users can integrate this data into the workflow. So a nurse would have the ability to renew a medication, and so this would eliminate the need for data entry during a visit. However, one thing to keep in mind is that this type of conversion is more work on the side of the conversion analyst and also on the client side. So we talked earlier about the mappings that need to be completed for a discrete conversion to ensure that the right data is going into the right fields in the EHR. Discrete conversions generally require more intense testing as well to ensure that data isn't being duplicated, so that can extend the timeline of the project. So for example, if a client is already live on Enterprise EHR and a patient from the legacy system is seen prior to the conversion, discrete data such as medications may be entered into the EHR during the visit, and then when the conversion is performed, it could duplicate the medication in the chart. So you can see here patient's chart in the EHR. All of these data elements that are seen on this page are stored in the database. So as I had previously talked about, we would have the ability to do reports on this type of data, and you can also incorporate this data into the workflow. So if you would chose to do a discrete conversion, this is how the data would appear. So one of the first decisions that should be made during the conversion process is what patient should be converted. It might be easy to think that all the patients from the legacy system should be converted. However, you need to keep in mind that there may be patients that are no longer active or seeing a provider in the practice, so their data will not necessarily need to be converted. A successful and well-executed demographic conversion from the practice management system is also important to a successful data conversion because all the patients will be in Enterprise EHR already, and so this will eliminate the patient matching errors during the conversion. Patient matching is crucial to the exchange of clinical information between the systems. So the Allscripts Enterprise EHR has strict matching criteria, which uses standard matching, which is matching on 3 of the 4 of the following. So there's name, which is considered to be the first 5 letters of the last name and the first 3 letters of the first name, date of birth, medical record number, and social security number. So if the MRN is used in a multi-org environment, the organization will also need to match that MRN, but that only applies if you have a multi-org environment. Extended matching logic has additional demographic information that, if applicable, can be used. So extended logic would include the use of driver's license number, phone number, address, mother's maiden name, and gender. One option that we've used pretty frequently with clients is to use the standard matching logic of name, social security number, and medical record number. And if that fails, fall back on a secondary logic such as exact name and date of birth. This is something that can be discussed with your conversion team when the time is right. The conversion analyst can also provide you with a list of patients from the legacy system that does not match the patient list in the EHR so that you can reconcile those prior to the conversion, and that can reduce errors. There are a number of reasons why a patient may not match. All standard and extended matching logic requires a single match for success. So if more than one patient is found in any of the scenarios, the patient will return an error and will not be matched. Some other reasons why the patient may fail include that the name may be spelled differently between the 2 systems, the patient may have had a name change after the demographic conversion and it wasn't updated in the EHR, or simply the patient just does not exist in the EHR. In a shared multi-org environment, there can be multiple practice management systems, so the MRN may not always be available as matching criteria because the patient could exist in the multiple orgs with different MRNs. So this really just becomes a problem if the social security number is not available, seeing as some patients may refuse to give out their social security number, and some PM systems will only store the last 4 digits of the social security number. So in this case, the other 2 number in the Enterprise EHR can be utilized during the demographic conversion, and you could put the legacy MRN in the other 2 fields, and that can add an element to patient matching, and it can really minimize the failure rate. So in the case of a multi-org system, a master patient index can identify patients across multiple systems by creating pointers to all identifiers that exist across the multiple systems for a given patient. This is especially useful in cases when patient data can change in one database but is not always updated in another database in the same system. So the patient is assigned a unique identifier that's used to refer this patient across the enterprise. The data from the master patient index includes the name, date of birth, race, ethnicity, social security number, address, demographic type information, and it can also include hospital stay information. So another consideration that you want to make is that if a patient merge has been performed between to merge two patients into one, the patient number that was deactivated will not be considered for matching. So that leaves only the new patient ID considered for matching. Deactivated patients are patients that can't be seen in the patient lookup screen even when the Show Inactive checkbox has been selected. So this next slide, this is not necessarily an issue that requires a decision to be made, but I just wanted to highlight this topic as it's just very important that the conversion analysts get access to the data in a timely manner. This can sometimes be a lengthy process depending on a number of factors, so making sure that the process is planned out ahead of time and started as soon as possible after the contract is signed is really crucial to keeping on schedule and staying on target for go live. Conversion analysts need to access the data so that they can build out extracts to pull the data out of the legacy system. They'll also need access to the legacy application so that they can review the medical record as well as the database to validate the data as they test out their extracts. There are a few ways to help the analyst get access to the data. If possible, it's really ideal to have the legacy system and target system be on the same network. So this makes it easy to remote to the different systems and to see the data and to perform testing. The analyst can run extracts over a link server, have access to the most recent data, and most importantly, scanned images will be able to be easily accessed. So we understand that this isn't always a possible scenario, so there are other easy ways that we can access the data. So setting up Galen SecureLink as a gatekeeper both at the target system and at the legacy system allows the conversion analyst to easily remote into the legacy and the target system. So in this case, the data will not be on the same network, so scanned images will need to be physically moved over to the target system. But there are ways of doing that I'll discuss in a second. And if you don't already have Galen SecureLink installed, we can have a network administrator at Galen that will assist you in setting it up prior to the project being started. The conversion analyst will put a staging database to hold data from the extracts on one of the test database servers at the target system. This should be on a different server. If this is on a different server than the test database, a linked server will need to be set up so that the analyst can test importing the data into the database or importing the chart summary data. The analyst will need a copy of all the scanned images to import into the scan warehouse in Enterprise. As we had discussed earlier, the ideal method is to have direct network access to the folder where the scanned images are stored, but we do understand that this is not always possible. So the analyst can also get access through a removable device at the legacy system so that a copy of the images can be moved to the removable device and then copied to the target system. And this is a process we like to do up front for the bulk majority of scans. The scan data can be tested, and then when it's time for the go live, any additional scans generated after testing was performed can either be moved over by the removable device or through an FTP. The process of getting scans is good to think about early on in the project, so I wanted to make sure that I addressed it here. So as we talked about for discrete conversions, discrete clinical data elements that are converted from the legacy system to the EHR are stored in the database. We typically get the question during the process of a conversion of how much space needs to be accounted for in the database and on the database server for this new imported data. Unfortunately, there's no general answer we can give on the amount of space that will be taken up in the database, but the easiest way to do this is to measure the size of the database, do a test import on a percentage of patients, measure the size of the database after the import, and then extrapolate the size difference based on how much the database grew from the beginning. So this is essentially killing two birds with one stone, as it's important to validate a large amount of test data for the test patients prior to go live. Also, it's important to take into account any scanned images that will take up space in the scan warehouse and in impact, so the same exercise can be done both for the impact database and in the scan warehouse. Non-discrete conversions work a little differently as there's minimal data going into the database. However, the chart summaries will occupy space in the scan warehouse and in the impact database. The chart summaries are estimated to be about 900 kilobytes per summary, so it's easier to estimate how much size will be taken up since there's one chart summary generated per patient, so you can multiply 900 kilobytes per patient that's going to be converted. So now I'm going to pass it back to August, and he's going to talk about some of our lessons learned during conversions.
Thanks, Fallon. So I just want to go over a few gotchas or lessons learned that we've had during our time performing clinical data conversions. So the first thing is when performing a document conversion, document or notes conversion, there are a couple things that you want to make sure of. So one is you just want to make sure that the auto CC flag, or the auto CC box, is not checked for any of those document types that you're using for the conversion. And this is going to be in the document type dictionary. So this can have some negative effects, like this can cause the PCP and the referring providers to be tasked about those documents that are being converted. And in some cases, it can even fax the note to a PCP or referring provider if that provider is not a part of the system or the organization and it has a valid fax number. And then it can also trigger a print job for each converted note, which obviously can cause a huge delay in the print queue if there are thousands and thousands of documents being converted and all of those are being printed. The next one is more of a reminder to really do test conversion workflows or test the workflows of the converted data during the testing period. If the correct site ID or correct site is not set for documents during the conversion, then anytime a user goes to print one of those documents after the fact, the documents won't print with the correct header information. So if the print templates that the organization has are set up to dynamically pull that site information based on where that information or where that note's being printed from, then it's very important to make sure that that site ID is set correctly. So the correct header information displays when a user goes to print that converted document. And then also, if new document types are being created for the conversion, and the desire is to have them not show in the application, not show up in the note selector window, then you just want to make sure that in the document type dictionary, you're marking those document types, the workflow for those document types as non-electronic. And this will just prevent those from showing up in the note selector window. Then with regards to both a document and image conversion, you want to be mindful if there's an outbound document interface set up. So this is going to apply more for production, but depending on how fast those documents or images are being converted, the outbound superset queue that sends those documents outbound on the interface can get backed up if the conversion is running faster than that queue is picking up the items in the queue. So those documents that are being converted will be entered into the queue. They're going to fail because they're not meant to go outbound, even though they are a document. And it can prevent real items like charges and orders from going outbound on the interface. So if that's the case for your organization, then your conversion technician can run a script that's going to keep the queue backlog empty. So anything that really does need to go out will be going out. Then the last thing to watch out for is those legacy systems that allow users to rename items within the EMR application without a user having to remove the item and add the new one. So this can really cause confusion when it comes to mapping and testing. One thing I've seen in a previous conversion that I did dealt with Allscripts Professional EHR, and this system allows users to rename items. So I saw a case where a user had renamed an allergy of cockroaches to horses. So on this chart, it displayed as horses, even though the actual discrete value that resided in the database was cockroaches. So as you can imagine, this can cause a lot of confusion. If it's caught prior to mapping, then you should be able to just map to the version that's renamed. So your conversion technician can just pull all the ones that are renamed and use those as the actual name to map to. However, if it's not caught prior to the mapping, then you'll have to make a decision. There are a couple different options there. You could still convert the renamed items as they've been mapped. However, this is going to cause a little bit difference between how the data looks in one system and how it looks in the other, since in the source system it will look like the renamed item, and in the target system it would just look like what the item actually is added to, how it's actually added discretely in the source system. Then you could also remap all those items if you have the time to do that, or else just not include those items at all in the conversion. So there are a couple of different options there, but you definitely want to catch that before the mapping happens, if the source system allows users to do that. Okay, so that concludes our presentation for today. Now I'll pass it back over to Fallon, who's been compiling the questions for a Q&A session.
Thanks, August. So we have time to take a few questions. If you ask a question and we're not able to get to it now, we'll just post our answers on the wiki, so make sure that you check it out there if you've asked a question we haven't been able to get to. So one question that we got, what about any new items that were added in the legacy system after the initial extract was taken? How do we include those items in the conversion?
Okay. Sure. So we actually get this question quite a bit from our clients, pretty common one. So there are usually a couple of different things that we can do. It depends a little bit on the source system that you're converting from, but like I mentioned, for those source systems that allow a lot of free texted items, what we generally request or say to clients is that as soon as the first extract is taken, tell your users or instruct your users to not enter any more free texted information, because the more free texted information you add after the first extract, the more that you might have to map later. So we usually say that. And then another common thing that we can do is, to, as it gets closer to go live, just take another extract maybe a week or so before go live, and then perform a few kind of catch-up mapping exercises for each of the data types. And this should just catch any new items that have been maybe been free texted in, or just new items that weren't used in the previous extract. And this should just catch us up.
Okay, thanks, August. Another question we got, why does the conversion only grab the most recent instance of each item?
Sure. So yeah, it's a good question. Most EMR systems that I've dealt with store, including Enterprise, store each time a clinical item is interacted with or added in some way, they store that as a separate record in the database. So, you know, let's say we have a diagnosis and it was assessed 3 different times on 3 different dates. Each one of those records is going to be separate in the database. So you can see that if we were to extract every single one of those records and convert them, then we'd have 3 of the same diagnosis in the target system. We'd have duplicates. So we generally extract the most recent record. You know, this gets any the most recent date information, any of the most recent comments that have been added, the most recent user, etc. So that's why we extract the most recent version.
Okay, thank you. And then another question we got, what do we do when a patient is not able to be matched? So this is another great question. We actually get this one a lot from clients. It's a common concern. So basically, there are a few different options you have if some of your patients fail during patient matching. The analyst that's doing the conversion can provide you a report of patients that failed. They can perform sort of a matching exercise prior to the go live, and they can identify any patients that would potentially fail during the go live, and that way you would be able to go in and you'd be able to update the legacy system or in the EHR and sort of fix the reason for the error prior to the go live. So, you know, that would be something like updating the patient's last name or some other piece of information so that it matches in both systems. This is a good opportunity. You could also add any patients into Enterprise EHR that might be missing from the legacy, or that might be, you know, not being able to be matched. So the analyst can also provide a one-on-one mapping exercise, and so that can map the patient in the EHR to the patient unmatched in the legacy system, and then this can be added to the conversion logic during the import so that it will be able to be accommodated for during the conversion. And then there's another option that we kind of like to call a last resort, which is kind of to manually abstract the information for the patients that can't be mapped. And then you're going to want to manually enter that data into the target system. So as you can imagine, this can be very time intensive as you're actually going through the data entry. So this really should be only a last resort option that you'd use if you didn't have very many patient matching errors, or if your project was on a tight timeline and you needed to sort of get it done pretty quickly. So those look like all the questions that we have for right now. If you end up asking a question that we don't get to, just make sure that you check our wiki, and we'll be able to post these questions and also any other questions that we get from that. So be sure to check out our blog, and I had had it on the previous slide. You can see some of our success stories, and you can read some testimonials of some of the legacy systems that we've worked with and what our clients have sort of said about us. And if you have any other questions, also you can visit our website at galenhealthcare.com.
All right, thanks everyone. Thanks for joining. Have a great day.